Hello, guys. Welcome back. Welcome to the IOQM session. So today we will be discussing problems as we do, and all the best for IOQM of this 2021. I hope your preparation is going good. Let's start. Okay, let's start. Okay, so let's wait for the students to join. In the meantime, you can try out this problem. Okay, guys, you can try out this problem. Okay, so let's try out this problem, guys. Um, there will be around around four problems. It can be more than that. There's another live from 8 from Chinta. Okay, so I kind of think that we have to end before 8 today a bit. But yeah, I will try to wrap it up and discuss all the problems and get red details. Okay, so here's the problem. First problem that yeah, this is a really interesting problem. Okay, I like this problem because you're gonna relate to it. So what you're doing is that you're actually moving around a spiral maze as follows. You start from 0 comma 0 and you move here, and then you move here, 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 and then you go ahead. Okay, so the question is that where will you stop at the 2005 stop? Okay, so this is first, second, third, fourth, fifth, sixth. Okay, the very interesting question is that where do you stop? What is your 205th stop, guys? Okay, that's the question. That's the usual question over here. Okay, so and IOQM is this coming Sunday, I guess. So all the best for you guys. All the best to you, rather. Okay. Okay, so let's try out this problem, guys. The problem revolves around the fact. So let's try to understand what are this problem like correspondingly, like how to attack this problem. Okay. So do you have any ideas? Brute force. But suppose it's asked to find the nth step. Can you find the result of the nth step? Can you find a formula for the nth step? Like what will be the nth step? Can you find a formula for that? That's a much more interesting, much more interesting question, right, Tisha? No, I'm sorry. It's tangent of triangle of circle. I thought both are same. Yeah. So do you think like there exists a nth formula? It's 3 comma, no, it's not minus 2 comma minus 23, Tisha. It's not that. So yep, so let's see. So let's try to find out the general result. Like, can you find out the general result, guys? Okay, so what we are trying to do. So let's try to understand what is really happening. Okay, so it goes from 0 comma 0, and then it goes to 1 comma 0, and then it goes to where? It goes to 1 comma 1, then it goes to 1 comma, sorry, 0 comma 1, okay, and then it goes to 0 comma minus 1, then it goes to, sorry, not 0 comma minus 1, I'm so sorry, 1 comma, sorry, I'm so sorry, yeah, 0 comma 1, and then it goes to minus 1 comma 1, okay, and then it goes, try to understand these points, okay, these points are important, where it turns around. So what are these points? Let's check it out. Minus 1 comma 1, and then it goes to minus 1 comma 0, and then it goes to minus 1 comma minus 1, and then it goes to this. So observe that this is a like, this is all x comma or x. So observe this one, okay, this one. These are all the corner points. X comma minus x or x comma x. Yeah, so how do you really mathematically formulate this? How do you really do this? So can you give me an idea how to really proceed towards this problem? How do you really proceed towards this problem, guys? It's really important. Some spirals is going on, so how really do you proceed? That's really interesting to understand. This type of questions can come in IOQM, okay, for sure. So yeah, tell me. Yeah, of course there is something going on. So what is going on? So it's 1, here it's 2, 2, 3, 3, 4, 4, 5, 5, then 6, 6, and it will go ahead, okay? So to understand that when are the like these things are coming, okay? It's coming after how many steps? So it's 1 plus 1, then 2 plus 2, okay? So the first is coming here, then the next is coming here, then the next one is coming here, then the next one is coming here. So you need to find, we are trying to identify these points, okay? We're trying to identify these points. So here it was 0 comma 0, then it comes here, then it comes here, then it comes here, then it comes here, then it comes here. Okay, we're trying to identify this. So where will we be after these steps? Here it's not like that. Oh, it's not like 0 comma 1, it's on the different way out, okay? Observe that all the points are they in fact on a straight line? No, they're not on a straight line. Or rather, these points are on a straight line. Yeah, these points are on a straight line. Yes, so you can calculate these points, okay? Where do these points lie? So it's 1 comma 1 it happens, and then it happens at 2 comma 2, then it happens at 3 comma 3, okay? But after how many? Yeah, you're right. So hello guys. Yeah, you missed, we are doing a single problem. Let's see what problem we are doing. So we are doing this problem, okay? We are moving along the spiral and we are trying to find out the nth step, the result of the nth step. How do you find the nth step? So here it was 0 comma 0 at the starting, then after 2 steps it is 0 comma 0, after 2 steps it is 1 comma 1, and then after 2 2 3 2 2 3 4, so therefore it turns out that 2 plus 2 plus 3 plus 4, it is 1 plus 1, is 2 plus 2 plus 3 plus 3, I guess, I'm so sorry, 3 plus 3, this number of steps ke baad is 2 comma 2, okay, and then it's coming out 3 comma 3. So we are sort of trying to find out the function, okay, so of the nth step which gives rise to the position of the points. Is there a function or is there a recurrence relation? That's what you're trying to find. Okay, that's what our aim is now. So what is the so yeah, the question is easy here. What is the x coordinate of the point? Okay, which we arrive at the 215th stop, 205th stop. So this is really interesting, you know. So you can do it in two different manners. You can see how x is going and how y is going. That's a very interesting and that's an interesting approach, you know. How x is going and how y is going. That's a really interesting approach. So try to understand that because that will identify your. So you try to find out xn and yn, okay, at the nth step. So let's try to see how x is behaving. Okay, let's try to see how x is behaving. So it goes from 0, then it goes right, okay, and it goes to 1, and then it remains same, okay, for 1, and then it remains it remains 1, and then it goes left to 0, okay, and then to -1, and then it remains same for 2 steps, okay, and then it goes to what? So try to understand this sequence. 0 1 1 0 -1 -1 -1 -1. Sorry, is it fine? -1. I did one times more. Not -1 -1. Then again it's 0, then +1, then +2, and then it will again stay. Okay, so 0 is one stop, 1 is next stop, -1 is the next stop, and then 2 is the next stop. Okay, and you will get 2 here, and then you get 2 2 2. So 2 2 2, okay, and then you again go to 1, then -0, then -1, okay, and then you go to what? 2 1 0 -1 -2 you go, okay, and then there's another stop, and you get to -2 is again another -2 -2 -2. So how do you find this sequence, guys? How do you find this sequence? So this is a very interesting sequence, right? So it goes to 0 and 1, then it's going back to the negative of it, and then again it's going back to the positive of it +2, okay, +1, and then it just do like this. How can you really find out the nth value of this sequence? Similar, because it will be almost similar to the like y, actually, you know, the y behaving. How do you really approach this problem now? So this is the sequence that is happening: 0 1 1 0 -1 -1 -1. So -1 stop, and then 2. So how do you really find out what is really happening? So tell me the method, tell me the algorithm. So Tisha, you had some ideas now. How did you find it out? Tell me, how did you find it out? How do you find it out? Tell me. What's on your mind? Yes, so think about it, guys. Think about it. Yeah. Think about it. How really are finding. So rather my question is that why don't we do these stop places? These places where we are stopping. Why when you do that? Okay, that's my question. One, so on, so 1 1 2 2. So 1 is there, and then we are moving again. So let's try to understand. 1 is there, and then after 1, it's going to 1 + 1 2 4 6. Sorry, 2 4 6 over here. Then 9 12 16. Okay, so 1 over here, 4 over here, okay, and observe this, then 6 9 over here, and then observe it, it's 3 12, and then 4 16 over here, and then 4 5 and 25 over here. So understand this very carefully. 1 is happening over here, so understand this very carefully. I'm again explaining it to you what is really happening. what are the stop numbers? So here it's 0 comma 0, right? So after one step it's this, right? 1, and it's 0 here, and let's try to understand the stop number. And after one step, 1 1 2 4 fourth, let's try to understand the square. Then 2 6 and then 9 here, okay, and then again 4, and again 3 and 4, 12 and 16 here, and then again, if you can understand, this is 25, and this will continue, right? See this pattern, right guys? You see this pattern over here? So this is the idea. You see this pattern, you need to use this pattern now. You see this pattern? This is a pattern, so you need to use the idea now. Okay, so it's like 0 1 4. So now what are these numbers? Can you tell me what are these numbers? What are these numbers happening over here? Try to understand it. What are these numbers? So these are on this line, and these are on this line. This is on this line. So how do you find out? Observe that once you find this out and this out, the next one out, now the next one out, you can easily. So if essentially what you need to find out is, you need to find out two consecutive squares, n square and n plus 1 square, okay? And then if you find out a number, so if you ask that, find out the k step, so you find out k between n plus 1 square, okay, and n square, okay, and then count from there, you know, where the n plus 1 square and n square will lie. So therefore that's our algorithm, okay? So that's our algorithm. So what we will do is the following. We'll find out the where the n square and the n plus 1 square will lie, okay, where the even squares and the odd squares are lying. These are all the odd squares. The odds, observe that all even squares are all lying in this direction, okay, in the above direction. So if you observe it, what is this number? This is minus this is minus 1 comma 1. This number is minus 2 comma 2. Am I okay? Yeah, this is minus 2 comma 2. So essentially, yeah, and this next one is minus 3 comma 3. Similarly, you can find it out here. What is this number? This number is 0 comma, also the 0 comma, the sorry, not 0, 1 comma 0. The next number, observe it, what is this? This is 2 comma minus 1, you see, and this is what? 2 comma minus 1, and this is what? Observe this very carefully. 3 comma minus 2, right? Can you see the now? Can you see the pattern over here? What is the number happening? 1 comma 0. Okay, let's see the pattern. Okay, let's see the pattern. So let's try to rub it off here. So this is a very intense problem. Okay, I like this problem actually. This is how you observe patterns. Okay, so observe this very carefully. Now you have got 0 mein 0 comma 0. Okay, 0 comma 0 mein 0th step. Okay, then 1 comma 0 mein first step. Then minus 1 comma 1 mein second step, fourth step, 2 square rather. And then what? 2 comma minus 1 mein what step? 3 square step. Okay, and then you have minus 2 comma 2 mein 4 square steps. Okay, and then you have 3 comma minus 1 mein 3 comma minus 2 mein, sorry, 3 comma minus 2 mein 5 square steps. So this is understand. Can you understand the pattern now here? What is happening really? Can you see the pattern over here? Can you see the pattern? I think you can see it most probably. So observe that how do you, so I hope you can see the pattern, right? So this is how you see the pattern. So therefore, how do you find out? Therefore, n square ke liye, so if for all n square, so for, observe this very carefully, okay? For, observe this one thing very carefully. If you take, so this n square, if it's x comma y, okay, observe this very carefully. It's 1 is here modulus 1 plus modulus 1. 4 is here modulus minus 2 plus modulus 2. Okay, that means 4 square. So this sum is actually the modulus of the positive magnitude of the coefficients. Okay, some of the magnitudes of the coefficients. Square is this. Okay, So therefore, how do you rather do it? It's 0, 1, minus 1. So if you just check it, that 1 का देखो, 3 square का देखो, and 5 square का देखो. If you see the odd places, you see that the first one is if it's 2n plus 1, the first one is n plus 1. The next one is just give me a moment, n plus 1 and minus n. Do you see that, guys? So therefore, for 2n plus 1 square, it will happen at n plus 1 comma minus n wala step. Okay, you can prove it by induction. Okay, you can all prove this by induction, and therefore observe that the event will happen at what? The event will happen easily. You can see it easily. The event will happen at 2n square will happen at minus n comma n. Okay, you can see it easily from the pattern. You can easily see it from a pattern, right? Minus n comma n. So therefore, what is the algorithm? You take any number lambda and you put it between two squares. Okay, put it in two squares, and you know that these are two endpoints. Okay, these are two endpoints that are coming towards either this or this to this, and therefore you know where they are coming. So therefore, wherever lambda is, just count it down from there. Okay, that's it. That's how the algorithm is about. So 2005 ये इसका square root क्या है? Let's find it out. 2005 is square root of, just let me check, of 2005. So it's happening 44.77. That is, it lies within 44. It lies in 44 square and greater than less than 45 square. So let's try to understand. All of you understanding this, guys? Any doubts, guys? All of you understanding this? So what is really happening? So you have got for 2n plus 1 square. Okay, the number is n plus 1 minus n. For 2n square, the number is minus n comma n. Okay, that's what the answer is about. Now 2005 is less than 45 square and is greater than 44 square. So therefore at 44 square the number is 44, that is minus 22 comma 22. Okay, and here it's 45 square is by 2, what it will be, 22. So n23 comma minus 22. Okay, therefore what do we get? Minus 22 comma 22 is here, and you are going towards, sorry, yeah, and you are going towards 23 comma minus 22 here. So here is the path. Okay, and how many such positions will be there? So you know this position, right? Remember, these are all equal. Are they equal? Are they equal? Just check it out. Just check the diagram, guys. Let me show the diagram. Check this diagram out, guys. 1 2 3 4 1 2 3 4 5. So 1 second, guys. And therefore what do we get? Yeah, sure, Pranav, let me explain the problem once. Let me finish explaining the problem. So therefore what do we get from here? How much do you have to cover from here to here? So therefore you have to go down from 22 to minus 22 here. That is how many steps? Count the x number of steps and x plus 1 number of steps. Count it, guys. How many steps? What is this? This will be minus 22 comma minus 22, right? So what is the x number of steps over here? So yeah, count it out, guys. Yep. So I think it will be 44. So I think it will be 44 and it will be 45. Okay, that many steps over here, guys. Okay, and therefore if you count the number of steps, you get that. Yeah, so therefore what is this? Wow, what is this between? Let's see. 2005 minus 45 whole square, 2005 minus 44 whole square, sorry, 69. So 69, where is 69? Let's see, 69, where is 69? So 44 over here and 69 lies over here, so 44, and therefore rest of the 25. So therefore it's minus 22 comma 25, that is 3. So here it's minus 22 comma 3. That is the point. All of you got the solution, guys? All of you got the solution? It's minus 22 comma 3 is the solution. Did you get it, guys? Any doubts? All of you understood the algorithm? Okay, Pranav, our course structure, you can apply in our website, and you can, our support team will call you and you can ask any stuff. So I don't know which course like you are interested in. If it's for IOQM, we have Math Olympiad where you have various labs of deliverables and classes. So yeah, so we have a lot of problem solving sessions. We have 3 problem solving sessions of IOQM every single week, including this. So yeah, you can do a lot of problem solving and mathematics with us. So you just can go to www.chinta.com and you can sort of apply for a trial class there. And then after the trial class, if you're selected, you will be yeah, first of all there will be a trial class, and then if you're selected, then you will be eligible for the course, and then things will go ahead. Yeah, sure. So did you understand that here we will be at the 44th square step, and here it will be 45 square steps, and 2005 is 69 steps ahead from this. So it is going from here to here, right? So 44 over here and 23 over here, 25 over here. So you know, after 44 it will be minus 22 comma minus 22, and after 25 it will be minus 22, and then minus 22 plus 25, that is 3. So here it is. Do you understand, Tisha? All of you understood it, guys? Any doubts? Any doubts, guys? Any doubts? Oh, sorry, Tishika. Sorry, Tishika, did you understand it? Any doubts? Which part didn't you understand? Tell me, otherwise I will move on to the next problem. It is a lovely problem. So therefore, suppose you're writing a computer algorithm, okay? So if someone knows a computer algorithm, let me know and I will check their solution, okay? You can give me the algorithm. So how do you find it? Suppose I tell you that to find out and pinpoint the location of a point, okay? So how do you find? We have not found a general formula over here, but we can easily find out over there, okay? So what is the general formula for a number? I think you can easily like find a general formula. So if it's n, you can sort of find out the closest like root over n ka, so essentially closest root to a number. So we can find out general formula like this. I love making these formulas. So for any nth step, the closest the closest square is n is between this, na? So okay, there are 2 cases. If it's even or odd, we have to check if it's even or odd. Suppose if it's even. So suppose we can find out. Suppose let's say we have to do 2 steps. So we take n. If it's even, if root n box is even, we have a different algorithm. And if root n box is odd, we have a different algorithm. So it's odd. Okay. If it's odd, if it's even, then what will happen? Let's say if it's even is equal to, therefore this, it will be going towards. So therefore you have to go n minus root n box more steps from if it's even, then what will happen? If it's even, then it will be 2n square minus, so yeah, it will be minus root n box to box root n, okay, minus, and yeah, minus, yeah, this one, and 2 some, so you know that what is coming up, box n plus 1 and minus root over box n. You know this is coming up, right? So you go from here to here in this many steps. Okay, and you like the blockage is at, you can find the blockage. The blockage is just minus box of root n. So you go like this now. So if it's even, observe this is always even, this is always odd. So it happens at minus box of root n to box of root n, minus comma box of root n. So you go through this and then find it out, okay, what really happens over there. So you can find out a general algorithm that what really happens, okay. And if you can write the algorithm and implement in a computer, the computer will be really happy and I also be happy. Oh, this is a famous programming problem? I didn't know that, tangent of a circle. Okay, yeah, I love this problem, so you can really find out this programming problem. It's really easy, okay, but it's really interesting too. Okay, so you can find out for each, so for if those people are giving ZIO, this is an important problem. So you can find out the algorithm and then you can implement in C or Python or whatever you want if you're giving ZIO, okay. So I think it's an interesting problem for you. Anyways, so it also enhances your algorithmic power. Okay, okay, okay. So let's do the next problem, guys. A lot of time being wasted over here, not wasted but enjoyed over here. Okay, next problem is really easy. So find the number of even digits in the product of these two. It's really interesting problem. So if you do this product, how many even digits will be there? Very good. Tangent of, I don't know what's your name, tangent of a circle, but it will be really good if you can share your name. You solve this type of problems, right? Tangent of a circle. Practice problems like this. Okay, so let's do the next problem, guys. How many number of events? So what I do personally, I don't do, but I personally feel is that whenever there is a problem now, Shubham, whenever there is a problem like this, mathematics or number theory or combinatorics, always try to find out how to code it. Okay, so if you find that way out, always in the back of your mind, you will always think in terms of algorithms and always reconciliation and this stuff comes up. So you want to be good in discrete mathematics and always try to reform the problems of discrete mathematics into algorithmic format. Okay, so I think that will really help you out. I personally feel so. So always think for, yeah. So yeah, how many? But how do you find it, guys? Tell me the way out. Okay, so Shoradeep is trying to find out a pattern in here. That's really interesting. But can it be done in an easier way? It's really, yeah, that will really make you better in. See, ZI is nothing but a combination of mathematics and computer science. Okay, so if you do good in mathematics, so computer science may itna like, of course there is a need for reduction of the time of output, like time of running of the algorithm. But if you think about, so first you should think about how the mathematics, and then you should make hard think about implementing it, and then next step you should think how to implement in a shortest possible way. Okay, so that's the next part. Okay, let's not talk about this. Let's Shubham, let's go into this problem. Okay, this problem is I mean, you don't look for patterns. There's an easy algorithmic way out to compute it. Sauradeep, can you go? Can you tell us, guys? There's an easy algorithmic pattern over here. In fact, you can do it for n's. N's. We will do it for n digit numbers then after doing for 10 digit. So have you prepared for IOQM? Like, are you giving the IOQM? No, but why is this true, Sauradeep? Can you prove it? Can you prove it? What will come up? Why this is true? Just solve problems through. That's it. Okay, that's not the way. Okay, so people are going the right way. So the easiest thing is to do this. Just replace this. So let's do it for 10 to the power 9. Okay, so there's suppose say n digits are there. So what it will be? It will be 2 2 2 n times, let's do this. So what is this? N nines are there, so can you tell me what it is? Suppose two nines are there, that means it's 10 square minus 1. For n nines it will be 10 to the power n minus 1, right? So what is this? It is 2 2 2 n times 10 to the power 9 n, that means 0 n's minus 2 2 2 n times. So how do you do it? 2 2 2 2 2 n times 0 0 0 0 0 n times minus 2 2 2 2 a to n times. How do you subtract this, guys? So it's 8 over here, 1 over here. Sorry, 8, and then you get 7 7 7 everywhere. So n minus 1 sevens, and then again you get 1 over here, and then 2 2 2 2 2. So how many such there? So n minus 1 y 2's and 1 8. And how many odd? Rest of them odd. So how many total numbers are there? Tell me. Total number of numbers are 2n, right? So you get n even digits and n odd digits. Beautiful, clean, and super easy. Okay. Okay, guys. All of you understood this problem, guys? Any doubts? So there will be how many such digits? For n equal to 10, n digits are there. N even digits. Yeah, it's a really easy problem. Let's move on to the next problem, guys. It's a geometry problem. So in the problem, AOAB with triangle angle AOB is equal to 90 degree. OB is equal to 13. Okay. And P and Q are 2 points as that PQ is equal to 4 vertical height is PQ is 4 centimeter, and 26 AP is equal to 22 PQ. This is a weird condition, but yeah, 26 AP. Okay, so it's given the ratio of this. If you take the ratio x, then you can sort of tell it like what is the ratio. So it's x by 26. It's kind of weird, but yeah. So it's like AP is to PQ is to QB is actually 1 by 26 is to 1 by 22 is to 1 by 11, which turns out to be yeah. I take the LCM of it. 26 into 11. Kind of weird one, but yeah. 26 into 11 LCM, then you get here is 11 times 11 is to 13 is to 26. Yeah. So here is a ratio 11 is to 13, 11x times 13x times 26x. So here is the stuff you got, and therefore total is 11, 13, 26, that is 24, 50x. Here is 13x. So use this information. You didn't use this information as of now. So that's what I use this information. If we can do it anyhow, I'm not sure how to do it. Okay, we find OPQ, this triangle area. Okay, I will give you some time to think, guys. Okay, origin is a good choice, but I'm not sure how to use origin. But yeah, origin is a good choice. Origin is a good choice, but yeah, can we do it in a normal Euclidean way? Euclidean way. Think about it, guys. Yeah, think about it. I am giving you some time. Hmm. Descartes is your best friend? Okay. Okay, think about it, guys. Let's see. Hmm. Let's see. What do you think? Hmm. PXQX. Okay, that's really interesting. I hope okay. So this is what we have got. What there he's telling. Okay, it's 13 centimeter over here, and he's telling that this is 11 is to 13 is to, remember, 26x. So he's telling that here it's we draw perpendicular, that is x. I hope that what is you mean, right, Omar? Yeah. Yes. So you can see that PQX is sort of similar to AOB. Of course, it will help, and this is this. So let's see which is the dissimilar. So 4. So this, let's see this angles. This angle is equal to this angle, and this angle is equal to this angle, and this angle is always this. So what do you get? 4 by what? 4 by this, which we don't know, let's say y, is equal to 30, no, 13. This is along the cross. Let's do for dot. No, 4 by y. Sorry, now let's do for cross. I don't know this length, so let's do for this right angle triangle. That is 13x by 13x by 13x by 13x by 13x by. Let's see. 13x by 50x. Wow, 50x. So you got that y is equal to 200 by 13, and from there you can get x, right? 200 by 13, and then from there you can get x. 50x is equal to, by Pythagoras theorem, you can get x. Okay, qx is equal to 4. Yes, qx is equal to 4. And then how does that help? We get 13x, but how does that help actually? That's my question is all about. How does that help? It of course helps. How does that help? Because, okay, how does that help? Tell me. It's really easy now. So what is OPQ? OPQ is equal to this height h times this base, right? Half into, sorry, angle AOB, half into h into AB, right? That is 50x is equal to triangle AOB का area. ट्रायंगल OPB OPQ का एरिया कितना है? हाफ इंटू h इंटू what? 13x, right? ट्रायंगल OPB. So therefore triangle OPB triangle AOB कितना होगा? 13 by 50, right? Times AOB होगा OPB. ना AOB का एंगल कितना है? हाफ इंटू this, that is 13 by 50 times half into 200 by 13 into 13. At 100 and you get 2, therefore you get 26. All of you understood this, guys? 26 is the answer. Twenty-six is the answer. Did you get it, guys? Why this is 26? All of you got it, guys? Why this is 26? Or do I need to mention it again? Tell me, guys. Yeah, that's it. Yeah, that's it. That's actually it. Tishika, Ahana, did you understand? Very good, very good. Let's continue. Let's go to the next problem. In fact, I am telling you something, try to prove it, okay, somehow. I don't know how will you prove it. Try to prove it directly that it's half into 4 into 13 is the area of this triangle. Now I will not tell you how. Okay, this 4 and this 13. Okay, now you have to find out how it is actually true. Okay, try to find it out how this is actually true. It's not really easy to find it out, but you have to find out how somehow. Why this is 4 is coming up, why that is coming up, to find out it out. Okay. So somehow you can tell that this area is same as, somehow you can tell it like this, some area on that. You can sort of show it. Okay. So try to find out why this is true. This is also 26, right? So tell us this is actually true. Okay, anyways. No, we draw a perpendicular from Q to X. So you have to prove that this is actually half into 4 into 13. Okay. Why this is true? Directly. No, try to think easy, tangent of Shubham, okay? Not always hard things will help you out. Okay, let's do the last problem maybe for today. And yeah, it's a combinatorics problem. So using the digits 0, 1, 2, 3, 4, find the number of 13 digit sequences that can be written as so that the difference between any two consecutive digits is 1. This is an interesting problem. I like this. So you write a 13 digit sequence. It's not a digit, it's not a number. Okay, so first one can be 0. The 13 digit sequence such that difference between any two consecutive is 1 at most. Okay, so do this problem, guys. Think about how to approach this problem. Today's problems are really good. I like this. Actually, this type of problems can actually come in pre-RMO and IOQM, I mean. Okay. Okay. So yeah, try to find it out. So you can generalize this problem in two ways, okay? One way you can generalize it from 4 to n, and this number of digits can be from m, okay? You can generate this problem in 4 this ways. So how many such digits are there? So you can generalize this problem in such a way. So always think about in a problem so that you can form in a generalized solve it generally, okay? Try to solve it so that it will also enhance the like creativity of yours as a problem solver. Since this is 0, 1, 2, 3, 4 for the number of digits, 13 digit sequence, we're going to make a recurrence relation out of this. How do you want to make to find recurrence relation out of this? Tell me. So the recurrence relation will depend upon the last digit, okay? So suppose if you do it for n, it will be a recurrence relation consisting of a single number with the previous n depending on the last digit, okay? So do you think it's bad or good? What do you think? But yeah, reconciliation is important. But what do you think about this? So okay, I like this grid movement wala stuff. This grid movement is really interesting. Yeah, yeah, I like this grid movement wala problem. Okay, so this is really interesting. I like this. Okay. Yeah, so there are two type of movements. You see? Yes. So you have this. You are trying to go from here, or no, from anywhere. Say to a 13 digits, 13 step. 13 steps are possible, right? So how do you really formulate that? Just give me a moment. Just give me a moment. Let me think. So you can start from any place, say, and you can start from any place, say, and you can go, or yeah, you can go from, let's say, 0 comma 0, 0 comma 13, 13, yeah, wait a minute, 13, yes, 13, and yes, here it's, so 13 comma 0, you mean, here is 0 comma 13, and here is 13 comma 13. So you can sort of start from No, wait. How I am formulating this problem? Will it be in 5 dimensions? I'm just confused, maybe. So essentially, the idea is that within this square, you can start from any point. Not actually from any point. To start from this uh initial point of, say, no, wait, just give me a moment. Just give me a moment. So we are sort of trying to use the, yeah, you're right, Saurdeep. I'm trying to give a like, what should I do? I am trying to give it a, just give me a moment. One, three, four, three, four, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. So yeah. So this is the number of steps. Okay. The digit number. This is the first digit. What is possible? This is the first digit which is possible. Okay. It will be 0, 0, 1, 2, 3, 4. This is the first digit possible because there are 0, 1, 2, 3, 4 digits. And you cannot go out of this grid. You have to start somewhere and end at somewhere without like going out of this grid. How do you do that? That's the problem is all about. Lovely problem. Do you see the idea, guys? Do you see the bijection, which is called a bijection, the connection? You understand this is the digits. So you start from somewhere, say you start from 1 and then you can go to what? You can go like this or this. It's actually called a random walk, you know. And then you go here and then and come down. So this is the digit means. This is the idea. So there is an upper bound to this problem, okay? So observe that suppose you can go out, suppose you can take a path so just give me a moment. What is the answer coming out? What I'm trying to, okay, so what I'm trying to think is the following. The first time it hits the surface, it can and goes out. Just let me think, okay? Just give me a minute. Now, can you tell me how many ways are there from this end to this end? Can you just tell me how many ways are there? Oh, that is a problem. Yeah, I see, I see, I see, I see. Yeah, it needs a reconciliation. Yeah. So this is a really interesting problem. Okay, I like this problem. What I can do is that it's like the idea. The problem ID is actually in reconciliation. So what we will do is the following. So Sauradeep has already given the idea. Is that so? There are two cases. Okay. So actually, we will actually depends upon the. Sorry, what I'm trying this. So it depends. Suppose we are doing for n+1. Okay. So let's say it ends with 1, it ends with 2, it ends with 3, it ends with 4, it ends with 0. So we take cases. So what we tell that if its end is 0 or 4, why 0 or 4 we are taking? Because those are sort of the ending stuff. So if its end was 0 or 4, okay, so then we call it an. So tell me another thing. Then the extreme 0 or 4, 1 and 3. Okay, if it end in 1 and 3, if it end with 1 and 3, it will be, let's call it bn, and this will be cn. Okay, by the way, do you want me to discuss the IOQM problems next class of this exam that is coming on this Sunday? We can discuss those problems in the class. Okay, and then you can show the, so now if you do this bn, now if you do the for n+1th step, so you can sort of find out that you need to find out an+1. For an+1 is numbers which are ending with 0 and 4. It will be what? Numbers ending with 0 and 4 can be only 1 and 3, that is bn. Can end only with 1 or 3 because you can do only 1 down. For bn+1, that is numbers ending with 1 and 2, it can either come from 0 to 1. Here it can come 0 to 1, and here it is 1 and 2. Here it can from 1 to 2 and 3 to 2. Okay, so that is 0 1, say. So 0 1 can come and 3. So therefore is 0 1 and 3. That is bn plus cn. Really easy. And cn+1 is what? Cn+1 is the number of digits which is ending with 2. And it can count from 3 and 1 only. So here it also bn. Am I right? I think it's twice of cn. 2 say. Oh, here it also can come from 2. Yes, so twice of cn it will be. No, wait a minute. 2. Let me check once. I think I did some mistake over here. How to get bn+1? That is 1 or 3. 1 and 3, 2 can come from 2 and 4. 3 can come. And 1 can come from 0 and 2. Yeah. So therefore the other 2 occurs twice and 0 and 4 occurs once. So it's an plus twice cn. So here it is the idea. Okay, if you take this idea, therefore you get this reconciliation. Okay, and therefore you can easily find it out. And you can show it from here that is equal to Cn plus 1. So therefore An equal to Cn, okay? So therefore you get that An equal to thrice Cn, which is equal to thrice Bn, okay? Because An plus 1 is equal to Cn plus 1 and Cn plus 1 is equal to Bn plus 1. Wait, what I mean is happening? Yeah, therefore you're getting that Bn plus 1 is equal to thrice Bn. Therefore what do we get? You get that Bn plus 1 is equal to thrice Bn. That means if what is B1? B1 must be equal to 1, so Bn is equal to 3 to the power n. Okay. See here we can find out similarly. I think B1 is equal to 2. Sorry. 2 into 3 to the power n. Okay, that's it guys. So yeah, I hope you're understanding it. I understood it thoroughly and I love the problems today, and all the best to your IOQM session, and next day we can do the IOQM problems that came in the exam, okay? Until then, good night and see you in the next class. Bye bye. I hope you don't have any doubts, Tishika, Ahana, Tishya. I hope you don't have any doubts. Okay. Bye bye. Good night. Another broadcast will be starting. Sure. All the best.